Right, so in this video I'm going to have a look at the second series. I called it S2, and it's 1 minus 2 plus 3 minus 4 plus 5 minus 6 and so on. Now what I'm going to say here is that this particular series has been assigned a value of a quarter. So where does this value quarter come from? Now we can see again, as I said in the first video when we looked at the what was called the Grandi series, 1 minus 1 plus 1 minus 1 and so on, we assigned that a value of a half. It didn't converge to a half. It's not a convergent series, it's a divergent series, but we assigned it a value of a half. In this particular case we're going to assign a value of a quarter to this particular series here. Now let's see where this quarter can come from. I'm going to have a look at a couple of different methods. So let's have a look at the first one. Well, if we take the S1, the Grandi series, S1, we know is 1 minus 1 plus 1 minus 1 plus 1 and so on. We said that that was a half. Well, let's square this particular one here. Let's square the left hand side, square the right hand side here. Okay, so how am I going to do that? So I'm going to square this here, so I'm going to square this particular series here, and I'm going to square this here. Well, I'm going to write this out a particular way. I'm going to write it out like this. I'm going to take, well, we see on the right hand side anyway, we're going to get our quarter anyway. So let's see what we get when we square this here. So I'm going to write out this 1 minus 1 plus 1 minus 1 plus 1. We'll just do this. This is going to go on and on forever anyway. And I'm going to do the same down along here. Oops. And along here as well. Okay, so I'm just going to write it out. Just move this up a little bit. Okay, so I'm going to start with 1 minus 1 plus 1 minus 1 plus 1, and that's going to go on forever down along here like this. Okay, so let's do these. We're going to multiply these. We're going to multiply this by itself. So what kind of values do we get? I'll put the values here in a different color. Okay, so 1 times 1 is going to give me 1. 1 times minus 1, minus 1. 1 times plus 1, plus 1. 1 times minus 1, minus 1. Plus 1, and so on. Let's look at the second one. Minus 1 times 1 is minus 1. Minus 1 times minus 1 plus 1. So I think you can see what's going to happen here. We're going to get minus 1 plus 1 minus 1 and so on. Here we're going to get plus 1 minus 1 plus 1 minus 1 plus 1 and so on. And here we're going to get minus 1 plus 1 minus 1 plus 1 minus 1 and so on. I'll just do the last one here, plus 1, minus 1, plus 1, minus 1, plus 1, and so on. And it goes off in all these different directions here. Okay, so this is what I get when I multiply S1 by itself. Now, how am I going to add up all of these? Well, what I'm going to do is actually add them up diagonally. So I'm going to take this as my first answer here, and then I'm going to add these two. Then I'm going to add these 3, then I'm going to add these 4, and so on. What do I get when I do all of this? Well, let's just move it up a little bit and see what happens. Okay, so when I take S1 and I square it, what I'm going to get is 1. If I add these two here, I'm going to get minus 2. If I add these 3, I'm going to get plus 3. If I add these here, I'm going to get minus 4. If I add these ones, I'm going to get plus 5, and so on and so on. Minus 6, plus, and so on. So when I square my Grandi series here, I actually get this particular series here. 1 minus 2, plus 3, and so on. We know that this is half, so this here, we're going to assign this a value of half squared, which is a quarter. So that's one way that we've got this value of a quarter for this particular series here. Okay, so let's go again. Right, let's have a look at S2 again. S2 we are saying is 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus and so on. I'm going to write out S2 again. I'm going to add it to itself, but this time I'm just going to move it over one position. So I'm going to put the 1 over here, so I'm going to start here. Plus 1 minus 2 plus 3 minus 4 plus 5 and so on. Add these up. What happens? Well, S2 plus S2, that's two of them. That's going to give me two S2s. What happens here? I get 1 here, plus 0 if you like, and that's just going to give me 1. Minus 2 plus 1, that's going to give me minus 1. Add these two here, that's going to give me plus 1. Add these two here, that's going to give me minus 1, plus 1, minus 1, plus 1, and so on. So 2s2 is going to give me this series here again, this Grandi series. So I know that that's been assigned a value or equal to half. Okay, so divide both sides by 2 here, and I get s2 here equal to quarter. Okay, so that works again. Let's try another way, another method. Okay, so let's have a look at this particular series here. 1 plus x squared plus x cubed plus and so on. You can see that that's going to be equal to 1 over 1 minus x, possibly. Okay, I'll prove this in a minute, but really this is your basic geometric series with a as 1 and r is just x. So what happens here is you get a over 1 minus r, if you like, which is 1 over 1 minus x. Now this will work for the modulus of x, or the modulus of r being less than 1. So in other words, x has to be somewhere between minus 1 and plus 1. Now there's a little bit of creative accounting going on here in a minute, but I'll show you that in a second. Let's have a look at another way of proving this, if you like. If I take this series here on the left as, we'll call it, oh, you can call it whatever you like, let's call it m, is equal to 1 plus x squared plus x cubed plus and so on. Let's multiply left and right hand sides by x, so I'm going to do xm on the left hand side. On the right hand side, let's multiply by x, so x times 1 is x times x is x squared, x times x squared, x cubed, and so on. Okay, so let's subtract now. So what I'm going to do is take m minus x minus m. So I'm going to take the top line and I'm going to subtract the bottom line. So that will give me that will just give me 1 here. X minus x, that's just going to give me 0. X squared minus x squared, that's going to give me 0. X squared minus x cubed rather minus x cubed, that's going to give me 0 as well. So I'm just left with 1 on the right hand side and m minus xm on the left hand side. Let's just factorize the left hand side. Let's just take that m outside the bracket, and we end up with 1 minus x inside the bracket, and that's equal to 1. So that gives me my m here equal to 1 over 1 minus x, and that's what I got here for this particular series. Remember, m is just this series here. I just assigned this particular series as m. On the right hand side here I got 1 minus x. So that's just a little mini proof here. Now what I'm going to do here is, I'll just write that out again actually, and just start from scratch again. We've got 1 plus x squared plus x cubed plus x power 4 plus and so on, and that's equal to 1 over 1 minus x. Now we know that this is true for values of x between -1 and 1. Now what I'm going to do first of all is just differentiate both sides. So I'm going to do a little bit of differentiation here on the left hand side first of all. So I'm going to differentiate. Differentiate both sides. So left hand side, differentiate 1. Here you get 0, differentiate x here, you get 1. Differentiate x squared, you get 2x. Differentiate x cubed, you get 3x squared. Differentiate x power 4, 4x cubed, and so on. Now the right hand side, okay, so let's just do that here. Okay, so we can see this here. I'll do it in a different color here. Let's do it in, yeah, that color here. So this here is 1 minus x. 1 minus x to the power of -1. Okay, so we want to differentiate this. So how do you differentiate? Well, let's bring this power down here. So that gives me -1 anyway, and that's 1 minus x inside the bracket. And then I've got to reduce this power by 1, so that gives me -2 here. Now I have to use the chain rule here, so I've got to differentiate what's inside the bracket. So this becomes 0, and if I differentiate minus x, I'll get -1. So this here is what I get when I differentiate this here. So what is that? Let's see. We'll get, well, -1 times this minus here, which is going to be plus. So I'll end up with 1 over 1 minus x squared. Okay, so on the right hand side here I just end up with 1 over 1 minus x squared. Right, so that's differentiating both sides. Now this is the creative maths kind of end of things. What a previous mathematician did, this was Leonhard Euler, he decided that to set x is equal to -1 anyway. Now we said that x has to be between 1 and -1, but he just decided let's stick -1 in here anyway and see what happens. Well, if you stick -1 in instead of x, so x is equal to -1. So what do we end up with? Both sides. Whoops. Just move this over here again. So x is equal to -1. What do we get? So here we'll end up with 1. If I put a -1 in here, I end up with -2. Put a -1 in here, so that becomes +1, so I just end up with +3. -1 in here, so that should be cubed here, I think, is it? Yeah, that becomes -4, +5, and so on, minus and so on. On the right hand side, what do I end up with? Well, I just end up with 1 over 1 minus -1, which is 1 plus 1, and we're just going to square that. So on the left hand side I end up with the series that I started with, 1 minus 2 plus 3 minus 4 plus and so on. On the right hand side I end up with 1 over 2 squared, which is 1 over a quarter. Okay, so that's where that particular value of a quarter comes from. I've done it a few different ways there. There are other methods of showing where this quarter comes from, but they're the ones I'm going to look at, or I've just looked at anyway. Okay.